So again, like your makeup, your test makeup, again, I put the answer key up right here. Right, so I put the answer key here. It is due, I want to make it due June 11th, mainly because your marking period ends on the 14th. And I don't feel like grading work on a Monday. So again, get your stuff in by that Friday. Right? So every test makeup, again, it's optional. You don't need to do it. But if you want to do it, make sure you hand it in by June 11th. Okay. All right. Any questions about that? Any questions about the due dates? Please let me know. All right. All right. All right. All right. Let me just do some finishing touches on these edits. Oh, almost deleted that one. Oof. All right. So let's go over the answers. Now let's go over how to read the answer key, right? So the answer key is red, right? So each test version in the name, you guys all have different names for your test. So version one, the version name for one is it begins with a 5/14, right? So it begins with the date in the beginning. Version two, the date begins with a 5.14. All right, 5.14. So 5.14 is over here. It's all the way at the beginning. All right, all right. So the name of the exam begins with 5.14. Now version 3 has the date at the end. So version 3 has 5/14 at the end of the Google form. And version 4 has the date 5.14 at the end of the Google form name. Are there any questions about the naming scheme? Are there any questions about how to view your test? Again, you guys do have access to look at your own answers now. All right, let's go over the answers. Let's go over the answers. Number one. Number one. What is the electrical charge on an aluminum ion that is formed when a neutral aluminum atom loses 3 electrons? So you're losing 3 electrons. Do you become positively charged or do you become negatively charged? Positive. Right? So you become positively charged now. Which means you're left with 2 choices. You're either the first choice or the fourth choice. Now your answers are scrambled, so it might not be top and bottom, right? So, and you also might have a different version. So it's either going to be the first or second. So you know it's positively charged. So you have 3 more protons than electrons. And you know the charge of one proton, the charge of one proton is positive 1.6 times 10 to the negative 19 coulombs. So if you have 3 more protons, well, what you're going to do is just going to multiply the charge of 1 proton by 3. And there's your answer. Other versions, actually, before we go on to other versions, are there any questions about the logic here I need to reference or talk about? Okay. All right. All right. So now this question right here is literally question 12 on your practice test. It was question 12 on your practice test. Now, I did give you 3 days to go over this. My estimate, my personal estimate was that over the course of 3 days, if you were trying, you would get to around at least 15 questions, right? Over the course of 3 days. Because I did give you guys 3 days to like do this practice test. I didn't went over questions, right? That was my estimate. Now, I recall going over number 12. I recall going over number 12 in class. And I basically copied this question, changed the magnesium to aluminum, I gave some lore, right? I said that, well, the aluminum ion forms because you're forming aluminum oxide. So it's basically combining with an oxygen atom or 3 oxygen atoms. And the only thing I changed was the fact I changed the magnesium to an aluminum, and I changed it to losing 3 electrons. Question 12 on your practice test was lose 2 electrons. Question 3 on your practice, question 1 on your on this exam was losing 3 electrons. That's the only thing that changed. That mattered anyway. Other versions, I made it so that you had an oxygen atom. So this is the oxygen part of the aluminum oxide, and the oxygen atom gains 2 electrons. So if you're gaining 2 electrons, you're negatively charged. So it's either going to be the second choice or the third choice. And so 1 electron has a charge of negative 1.6. You multiply by 2, and this is what you get. Any questions before I move on? Any questions? Any questions? I'll give you guys 30 seconds to finish writing up whatever you need to write up. All right, that wasn't really 30 seconds. That was like more like 10 seconds. But if you need me to bring it back, just let me know. Number 2. Let's go to version 2. Yeah, let's go to version 2. So number 2 says an object could have which of the following net charges? Also, I want to explain something about number 1. Even if you didn't look at the practice test, question 2 and question 3 was essentially the same thing as that question on your test. Because if you lose 3 electrons, that means you have an excess of positive 3 elementary charges. So that's basically what that question was. Number 2, so when an object could have which one of the following net charges? So this question is like a possible versus impossible, right? It's asking you what are possible charges. You should know by now that an elementary charge is either positive or negative 1.6 times 10 to the negative 19 coulombs. You cannot have a partial amount of electrons, right? You cannot divide an electron in half. You cannot have half. You cannot have half of an electron. That's not possible, right? You cannot have half of this electron. You cannot have 3/4 of this electron. You must have a whole electron, right? You must have a whole electron. So these charges must be a multiple. It must be a multiple of positive or negative 1.6 times 10 to the negative 19. So what you're going to be doing is you're going to divide these numbers by 1.6, right? And so when you do that, you divide each number by 1.6. There's only one answer that gives you a whole number. And that's the second option. Other questions are different, right? So if you have a different version, the answer is different, obviously, right? I'll give you guys like a minute, 30 seconds to a minute to finish copying this down or doing whatever you need to do. Okay, let's move on. Let's move on. Now, this question number 2, was pretty much like question number 4 on homework 6.1. It was similar to question 1, it was similar to question 6, but it was exactly the same logic and process as question 4 on homework 6.1. Number 3. You reading this problem, you see how you see diagram shows 2 identical masses and they're separated by a distance of 6 meters. So R is 6 meters. Each sphere possesses a mass M and possesses a charge of positive 5.6 times 10 to the negative 8 coulombs. Right? And each sphere possesses that same charge. So you're doing the same exact number. Also, I'm going to move to version 3. So version 3 has a different distance. So I'm actually going to change it. So R is going to be 3. R is going to be 3. And the question wants you to find out what is the electrostatic force. All right, so what is Fe? There's only one formula that you've learned so far that deals with Fe and two charges. Right, it's KQ1Q2 R squared. And you know that K is 9 times 10 to the 9. So you're plugging in all your numbers at this point. 5.6 times 10 to the negative 8, 5.6 times 10 to the negative 8, divided by R squared, so it's 3 squared. So you put this into a calculator, and let's put it into a calculator. Let's do 9. So, and you get 2.8 times 10 to the negative 5. Right, you get 2.8 times 10 to the negative 5. 3 squared gives you 9. So you divide this number by 9, and you get 3.1 times 10 to the negative 6 newtons. So that's the answer. To put everything in perspective, 1 Newton of force, 1 Newton of force is the amount of force required to move a object that has a mass of 1 kilogram at a rate of 1 meters per second squared. That's the force. 1 kilogram could be like a water bottle, like a Poland Spring water bottle. Not exactly, but close enough. Think of how small this force is. 10 to the negative 6. I give you guys 30 more seconds to copy this down, to copy the work. And while you guys copy the work, I will take attendance. Whew, that was easy. That was quick. All right. So let's move on. Now, that question right there was exactly like question 1 on homework 6.2. It was the first question. The only thing that was different was that I switched the diagram. I removed the numbers. I wrote the numbers myself in the problem. That was the only difference. But it was the same solving process as number 1 on homework 6.2. Same exact logic. Number 4. Number 4 is the same thing. Except this time, except this time, you have one electron, right? So it says there are 2 test charges, 1 electron. So you have Q1 is negative 1.6 times 10 to the negative 19 coulombs. And 1 proton is positive 1.6 times 10 to the negative 19 coulombs. And so the distance here, r, 10 to the negative 9 meters. And they want to know what is your electrostatic force. And again, you're going to use the same exact formula. To be honest, even before you attempt this formula, is this attractive or is this repulsive? A proton and an electron. That is really an important question. I'm going to wait until someone answers. Yeah, it's attracting, right? So you know it's attractive. So really, you're left with two choices. And even if you get the math wrong, really you have a 50% chance of getting this question right because you know it's attractive. So it's either one of two choices. So let's do the math. So K is 9 times 10 to the 9, right? Q1 is negative 1.6 times 10 to the negative 19. Q2 is positive 1.6 times 10 to the negative 19. R squared 1 times 10 to the negative 9. So you solve this problem, you solve for the numerator. What you get is you get 2.3 times 10 to the negative 28. You square the bottom and you get 1 times 10 to the negative 18. And you finish solving this, what you get is 2.3 times 10 to the negative 10 newtons. And it's attractive, so it's this one. This question right here, was essentially question 2. It was basically question 2. And it was basically question 5. The only thing that was different was that instead of 2 electrons, you have 1 electron and 1 proton. But other versions had 2 protons, other versions had 2 electrons. It depends on which version you had. Oh, man. I'll give you guys 30 seconds to a minute to finish copying this down. Yes, I do. I'm not gonna say it. I mean, I would, but this is class time. Maybe after the 14th, I'll tell you, but not now. This question. Yeah. All right, let's move on. Let's move on. So Electric fields. So the problem is asks you which electric field represents two positive charges, right? So you're reading this problem and you look at the answer choices. Well, it's not really a math problem. It's a concept problem. So sphere A has a charge of positive, right? And so does sphere B. So both sphere A and sphere B are positive. Now, if you recall, I gave you a go formative, right? I gave you a go formative where you basically drew, well, I talked about this in the Google Slides as well, right? The arrows from a positive charge point outward, things around a negative charge point inward, right? That's how the field lines are drawn. I even had you draw electric field patterns, right? And we went over them as well, right? We went over these electric field patterns. I had you copy them down. You copied my drawings down. So you should know, you should know that positive charges, you should know that two positive charges should have arrows pointing outward. So just by knowing that your arrows point outward from a positive object, you can basically eliminate two choices. Because in two of these four choices, arrows are pointing inward. So you know that these two choices are wrong. But you know that since they're both positive, they repel each other. And so the field lines of two positive objects look like they're curving away from each other. This question, besides not only being similar to your Go formative, to your classwork, where is this actually? It was similar to question 4. Question 4 says, which diagram represents the electric field lines between two small electrically charged spheres? I mean, also number 4 is like a possible versus impossible question. But it's really just based on your Go formative in your classwork. Not only that, you could have just Googled it. Electric field between a positive and positive. Right? If everything else was lost, you could have just Googled it. Other questions had positive and negative, right? If it was a positive and negative, then, well, you know that the arrows point inward here. And you know that it's gonna curve this way, right? Which leads me to question 6, because question 6 was also which one of these electric field lines are drawn correctly. You should know that electric field lines all point towards the same direction, right? If you're a positive charge, they point outward. They all point outward. And if you're a negative charge, they point inward. If you look at these choices, let's say you didn't know what A was talking about. Let's say you didn't know what this was. You move on to choice 2. Well, you see choice 2 has arrows pointing inward, right? So that definitely makes sense. These definitely make sense. Choice 3, you have arrows pointing inward at the top, but then at the bottom, you have arrows pointing outward, right? You have arrows pointing inward, then arrows pointing outward. They must point the same direction, either inward or outward. You can't have both on the same particle. So question 3 is automatically incorrect, right? So that's the choice you picked. So question 3 was the one that was right. Any questions about question 5 or question 6? Okay, guys. I'm gonna do the other 6 questions tomorrow. All right. I'll see you guys tomorrow. Have a good day.